Hey there, awesome 8th grade Turrentine science students. This is Mrs. Geis, and today we're going to be talking about energy. So go ahead and take out your LearnEd notebook entitled Energy. Open up to page 6, and we'll get started in a moment. I just want to remind you that you are welcome and encouraged to pause this recording at times where I ask you to reflect in your notebook. Also, just to catch up on your note-taking. Remember, an incomplete notebook is of no use to you. So make sure that you're keeping up with your notes and not only writing down the information, but rereading it and letting it really soak in. All right, here we go. Let's get started. On page 6, did you know that over 7 billion, actually about 7.9 billion people live on our planet Earth and use its valuable resources every single day? Not sure what a resource is? Well, a resource is a vital need that an organism has for survival. Resources are used, changed, and reused. Let's talk about resources, specifically water. We know that water is an extremely important resource. Actually, when scientists are searching for life on other planets, the first thing they're looking for is water, right? It is necessary for all life. How do you use water? Think about it for a minute. We know we drink water, right? But we also use it for cooking, for bathing, right? Imagine trying to cook spaghetti if you didn't have water. It would be kind of hard, wouldn't it? So think about how you use water every single day. Food, another extremely important resource that gives us energy, right? We need energy in order to not only get up and walk around and do the things that we do every day, such as exercising, going to school, thinking, but all the things that we don't see inside our bodies, right? All of those cellular processes all require energy. We need energy for life. How do you use food? You might be an athlete and you might hear your coaches saying, eat more carbohydrates before that race tomorrow, or eat more protein to build muscle. So think about how you use food. We eat food every day, but do we really think about how our bodies are using it? Shelter. Shelter protects organisms from harm. When I mean harm, I mean the elements, the cold, the snow, the wind, the rain, the sun, the heat. All of those things are extremely important for an organism to survive. How do you stay sheltered? Your family might live in an apartment. That is how you stay sheltered. Your family might go camping and stay in a tent. That provides you shelter. Imagine going camping and just sleeping out on the ground without any shelter. What would that be like? Space. We know that space is extremely important for organisms to live, to survive, and thrive. We talked about this when we did our ecosystems unit. We talked about needing a certain amount of space. Your space might be your own bedroom, right? You know that you need space, especially if you share a bedroom with a sibling. You might have partitioned off different parts of the room, right? Because you need your own space. Space can also be a yard outside of your house or apartment. It might be a place to grow some vegetables, to play some soccer. We need space. Here at Turrentine, we have large fields for us to play, for sports, right? We need space. How do you use your space? Again, something we don't normally think about, but it's important. It's a resource that organisms need. Air, hugely important. We know that photosynthesis and respiration are daily important occurrences on our planet, and in the case of respiration, inside our bodies, right? Photosynthesis, we know, uses energy from the sun and takes in carbon dioxide, which is given off during respiration, to give us things like oxygen, right? And glucose in the plant. Respiration takes in oxygen, right? And converts food energy into adenosine triphosphate, and it gives off carbon dioxide, which is then used by plants in photosynthesis. So it's a wonderful cycle. It's a symbiotic relationship. It means one occurrence one process helps the other process to happen. We couldn't live without plants and photosynthesis. We couldn't live without the respiration in our bodies. So we know that we were studying the air during our chemistry unit. We know that air is a mixture, and a lot of people think that it's mostly oxygen, but it's not. Surprisingly, it's 78% nitrogen in our air, the element nitrogen. Another 21% of the mixture of air is the element oxygen. And then that remaining 1% is made up of two more elements, neon and hydrogen, and also carbon dioxide. Remember, air is a mixture, and it is an extremely important resource. We know that we can't live more than about 3 minutes without air. Remember the 3-3-3 rule we talked about. You can't live more than 3 minutes without air. You can't live more than 3 days without water. And you can't live more than 3 weeks without food. Very important resources for us to live and survive. Plant life. So plant life filters water and provides nutrients. We've talked a lot about this in our hydrosphere unit. We talked about the estuaries and the mangrove communities. These are wonderful places where baby animals survive and protected and can grow up and get out into the larger bodies of water. We talked about the Everglades being a giant filter before water enters the oceans. Mangroves do the same thing. They filter, they protect the land. Their roots help prevent erosion and also provide a habitat for those young marine aquatic animals. How are plants essential to our survival? Think about trees. Imagine, what would the air we breathe be like without trees or plants or grass? And again, even if we're not eating the plant directly, remember that many of the other things that we consume, such as cows, beef, they rely on plant life and grazing so that they can survive. They're herbivores. Remember our food chains and food webs. Sunlight, again, extremely important. Without the sun, nothing on Earth would exist. It is the original source of energy. And remember, when we were doing our food chains and food webs, every single thing can be traced back to the sun. We need the sun. Sunlight is so important. Not only does it give us heat, it gives us energy, it gives us light. So let's talk about now some non-renewable and renewable energy sources. So oil. Oil is what we consider to be a fossil fuel. We'll talk more about fossil fuels during class, but fossil fuels, we call them fossil fuels because they go back to the time of the dinosaurs, when layers and layers and layers of sediment and debris and detritus fall down, get compacted, are under extreme pressure, and oil is produced. Natural gas is produced. Petroleum is produced. Oil is a non-renewable energy, which means that we can't replenish it faster than we use it. It takes a long time for fossil fuels to be developed. How do we use oil, otherwise known as petroleum products? Well, think about it. If you help your parents change the oil on their car, there you go. That is oil. We know that oil refineries are used so that we can use oil for heating our homes. It can be turned into gasoline, right? There are many different uses for oil. Something as simple even as fixing a squeaky wheel on your bike. Many, many, many uses for oil. But again, it is a non-renewable energy. Coal is another source of non-renewable energy. Again, it's a fossil fuel. It's formed in much the same way. We can't replenish it as fast as we're using it. Much of our electricity comes here in North Carolina from burning coal at power plants. So again, just turning on the lights in your bedroom, charging your cell phone, charging your computer, you can trace them back to coal, which is again a non-renewable energy. Natural gas, another non-renewable energy, We use natural gas for things such as cooking. I know in my house I have a gas stove and a gas oven. I can turn the button and a blue flame comes out and I'm able to use that energy to cook the food for my family. Natural gas is also used in my house to heat my home. So I get warm heat during the winter months by using natural gas. Also, in my house, my hot water heater is run on natural gas. So again, I can turn on the faucet and have wonderful warm or hot water, all because of natural gas, but it is a non-renewable energy. Natural gas is usually formed deep under the ocean bottom. Basically, again, a fossil fuel formed by all those layers of sediment and debris that fell and were compressed and subjected to pressure over time. We can't replenish it as fast as we're using it, so it is considered a non-renewable energy. Ask your parents, do you have natural gas in your home? Right? What do you use natural gas for? Non-renewable energies, again, are used so quickly that they cannot be replenished at the rate that they're being used. So water, let's talk about water again. Water is the most abundant compound on Earth. Remember, H2O, 2 hydrogens and 1 oxygen are chemically combined to make water. Water covers about 71% of the surface of planet Earth. And as a resource, all life depends on water. We cannot live without water. It is necessary for many life functions. Take a minute and think about some examples of the functions that rely on water. So water is known to have transport. It's known as a universal solvent. It is used in digestion and excretion. It is able to trap and store heat. It is used in cellular reactions, and water makes up body tissues. Remember, we said about 70% of our body is made up of water. How is water important to the functioning of life on Earth? Food, again, necessary to fuel cellular processes. Energy is the ability to do work. And I don't mean just go to a job and do your job. Anything that your body does is work. Even sleeping, right? Your cells are replenishing. Your body is still working, even when you're sleeping. As a resource, all life needs to obtain energy from certain sources. Many come from food. When these sources are limited, competition will occur. And remember, we talked about this when we did our ecosystems, and we're going to talk about it some more in a minute. So properties of water. Water, we know, has what we call polarity. That is the uneven distribution of electrons. One end of the molecule is more negatively charged and the other end is more positively charged. That's what we call polarity. Water has cohesion. This is the property that causes like molecules to stick together. So the fact that, remember we did the penny lab, water is attracted to other water, right? Water molecules want to stick together. Also, water has what we call adhesion. That is remember the stickiness. Remember I gave you the example of a Band-Aid. An adhesive Band-Aid sticks to your skin. Well, adhesion is the property that causes a molecule of one type to stick to another type. A great example would be rain on a windshield, right? Why does it stick on your windshield? How about dew droplets on a spider's web? That's a great example of adhesion. So how does this show cohesion? How does this show adhesion? I can see both happening. I see the dew droplets or water droplets sticking together because I know it because I have different sizes here on the spider web. And adhesion is the fact that the water molecules are sticking it all to the spider web material, right? So that is adhesion. Without adhesion, you wouldn't see the water droplets or the dew droplets on the spider web. So properties of water. Water has what we call a high surface tension. Remember we looked at the water striders, right? Cohesion causes water to have a high surface tension. So things like water striders are able to appear that they can walk on the surface of the water. Water has density. Remember, we've studied the mass to volume ratio. And there are certain things that affect the density of water. Remember, we talked about the salinity, the amount of salt present in water, right? When salt dissolves in water, the salt adds mass, but doesn't really increase the volume of the water very much. Colder water is more dense. The warmer water is less dense. Water also has what we call a high specific heat. Water absorbs a lot of heat before it begins to get hot. It also has a high heat of vaporization. Water is able to absorb a high amount of heat before it turns into a gas. So in class, we will be researching properties of water and doing some demonstrations to show some of these properties. Also, you can think back to the Penny Lab that we did way back at the beginning of the year in August when we were studying the hydrosphere. Because remember, the hydrosphere unit was all the water on planet Earth. So now let's talk about energy and resources. If you go ahead and turn your book to page 8. Food resources. These are necessary to fuel cellular processes. Again, energy is known as the ability to do work. As a resource, all life needs to obtain energy from certain sources. When limited, competition does occur. In ecosystems, organisms must compete for resources in order to survive. Remember, we talked about survival of the fittest, right? And adaptations will occur oftentimes when there's competition as well. Remember, genetic variation is the key to species survival. And the name of the game, guys, is survival. This competition occurs as populations grow quickly too. More organisms puts a stress on an environment, right? So there's definitely going to be competition for food and water and shelter and space, all the things that organisms need to survive. So population growth impacts the resources on planet Earth. In class, we will be doing the activity called Competing for Resources. That is on the bottom of page 8 in the orange box. Okay, so don't worry about doing that on your own. We will be doing that as a class together. Okay. Again, just for definitions, renewable resources. These are readily available and able to be replenished or renewed. You can get more, right? Non-renewable means it's used so quickly that they cannot be replenished at the rate that they're being used. You can't get more. Once they're gone, they're gone. Okay. So again, during class, we will be doing this activity. We're going to be dividing into groups and we'll be doing a competition activity together. I think you'll enjoy it. I'm going to skip over these for now. All right, let's look at sources of energy. So sources of energy at the top of page 9 in your book. The original source of energy for living organisms comes from the sun. Remember, every single food chain or food web can be traced back to the sun. This transfers energy to producers, right? Energy is then transferred to consumers throughout a food web. It is made up of living organisms in an ecosystem. Energy exists in many forms on our planet. We have so many different types of energy. Let's talk about a few of them. We have mechanical energy. This is the energy of moving objects. I know you talked about this a lot last year in 7th grade. We have chemical energy. This is energy stored in bonds. We have thermal energy, energy of moving particles. Remember, thermal means heat. Whenever you see the word therm or thermal, think of heat. Electrical energy. This is the energy of electric charges. Nuclear energy, and we'll be talking about this in our discussion of non-renewable energy sources. Nuclear energy is energy stored in the nucleus. Electromagnetic energy, energy that travels as waves. Energy cannot be destroyed. So just as we had the law of conservation of matter, we also have the The same law applies when we're talking about energy. Energy cannot be destroyed, right? It just gets moved somewhere else. Oftentimes, energy is lost in the form of heat. This just means that it has transferred or transformed in the form of heat. Transfer, one form of energy moved to an object as the same form. So, for example, kicking a ball, that is mechanical energy from the leg to mechanical energy in the ball. Chemical energy stored in a battery is converted to mechanical energy in a remote-controlled toy car. Describe the difference between energy transfer and energy transformation. So again, energy transfer is the same form going from one object to another, like in the mechanical energy, kicking the ball. Transformation means it is transformed from one energy type to another. So for example, the chemical energy stored in a battery is converted to mechanical energy. Make sure that you know the difference and understand the difference between transfer and transformation. Two very similarly sounding words or similar sounding words, but they have different meanings and applications. All right, humans use large amounts of energy to fuel our modern life. We know this to be true, especially when we have a power outage, right? When that power goes out, oh my goodness, life comes to a screeching halt. And we realize how much we appreciate being able to turn on that light switch and have light, being able to press that button and have television, being able to turn that knob and have heat to cook our food, right? To be able to power that microwave. We have become very used to our energy sources, and we depend on them. The increased need for energy due to advanced technology and mass markets. Different types of fuels have different environmental impacts on our planet. And that's kind of the meat of this unit, is the different types of fuels and the different environmental impacts they have on planet Earth. We're going to talk a lot about renewable energy sources, such as wind power, such as hydroelectric, solar, but they're not without their own problems. They sound wonderful in theory, but let's think back right now to what happened in Texas in February of this year. There was a terrible ice storm, and much of Texas's grid relied on wind energy from wind turbines. Well, guess what? They froze and stopped working, so people were really in a bad situation. So we'll talk about, Ms. Geis likes to give you both sides of every story, right? So that you can make your own decisions. Non-renewable energy, energy derived from a source that is used quicker than it can be produced. We've talked about that. Example, coal, natural gas, petroleum. Disadvantages of non-renewable energy. Well, of course, it will run out. It is expensive to obtain them, but obtaining them can also help economies of countries, and it causes higher levels of pollution. So when not done properly, harvesting coal, natural gas, and petroleum can definitely wreak havoc on environments. Let's think back to the Exxon Valdez oil spill that occurred in the 1980s up off the coast of Alaska, or the drilling platform explosion that happened in the Gulf of Mexico. It was catastrophic to the local ecosystem. So again, there is no perfect solution, guys. Oil. Oil is used to provide fuel sources. Petroleum, it's also referred to as petroleum. It is obtained from crude oil from oil rigs. And again, we see oil rigs, those drilling platforms out in the ocean. It can also be drilled, for example, if you visit Texas or Oklahoma, you will see the oil being drilled from the ground. We get from it gasoline, kerosene, and heating oil. Negative impact from using oil. When burned, it releases CO2, greenhouse gases into our atmosphere. It can be expensive, and drilling, when not done properly, can harm the environment. Natural gas. Natural gas is used to provide source of electricity or heat. Again, I mentioned in my home, I use it for heating and cooking and actually heating my hot water or my water. It is obtained from deep underground rock, oftentimes under the ocean layers as well. The negative impact from natural gas is CO2 emissions and limited supply. I will say that natural gas emissions are less than burning gasoline. So for example, in many cities you will visit, especially larger cities like New York, Chicago, Los Angeles, you will see citywide transportation buses and things powered by natural gas. That's because they are trying to reduce their CO2 emissions in those heavily populated areas. All right, coal. Again, here in North Carolina, we have a lot of power plants that burn coal. We have two main things here in North Carolina. We have coal and nuclear power plants, but coal is used to provide fuel sources, electricity and heat from combustion. So coal is obtained from coal mines. Negative impact of burning coal, acid rain. We see a lot of the effects of acid rain when we visit the mountains. Acid rain is detrimental to plants and trees and forests. The emissions from burning coal are also not good. And mining is harmful. Not only is it harmful to the environment, it's harmful to the people doing the mining, right? If you've ever known somebody who has coal miners in their family, they usually die fairly young. They have lung problems, and especially earlier in the 20th century when they didn't have the protective gear that they have today. But there are coal mining accidents oftentimes in our modern society. Coal has terrible waste. It's called coal ash that has to be disposed of, and it's hard to dispose of it without hurting our environment. And cancer, the carcinogenic effects of using coal or burning coal. So we, again, will research the following terms and explain in class together how they impact the earth. Don't worry about the chart because we will be doing that together in class as well. And that chart is on page 11, the bottom of page 11. So let's turn now to page 12, human impact. The larger the human population gets, the more damage we are doing to our environment. It's a fact. Using non-renewable resources faster than they can be replenished. We are causing harm to our environment, causing negative effects on ecosystems. We are releasing toxic emissions into our atmosphere from burning fossil fuels. Also, this is contributing to global warming and pollution, more recently known as climate change. We know that our climate is changing. Is this a naturally occurring phenomenon, or is this because of us burning the amount of fossil fuels that we are burning currently? We know, if we look at the history of planet Earth, it has gone through many, many, many different cycles of climate change. But that's something to think about. Is it because of us burning these things, or is it a naturally occurring phenomenon on our planet? We know that these toxic emissions endanger the health of many living organisms. If you suffer from asthma, you know that you will see on the news, it is going to be not a good day in the summer for you to be outside, right? When the air quality index is high, you know that you may have to stay inside. Okay, that's not good, guys, right? Human population growth, again, 7.9 billion people on our planet right now. It is exponential. Means it's growing at a very fast rate. It contributes more and more to ecological disruptions. Ecological meaning the ecology of our planet, the health of our planet. So methods to counter the negative effects humans have. And again, in class, we're going to be talking about this and recording some ideas that we have. What can we do to help our planet, guys? It's in trouble. All right. Natural methods that replenish resources. So this is what we need to look at. We want renewable energy that doesn't cause harm itself, right? That will be reliable and dependable when we need it. Water cycle. We know that the water cycle, we studied it a lot, recycles and filters water. Water is matter. Matter can never be created or destroyed. right? We know that it goes from liquid, it is evaporated, goes up into the atmosphere in the form of clouds. It condenses, we have precipitation, comes back to Earth, and the cycle begins all over again. Plants are extremely important, right, for the health of our planet. They clean and purify our air, right? Photosynthesis gives off oxygen, takes in carbon dioxide, gives off oxygen. So plants, trees, wonderful things. Plants in your home are proven to improve your air quality inside your home, right? And I know any house that Mr. Geis and I move into, we plant lots of trees. We love planting trees. Plants are a good thing. They help with erosion, they help with runoff, and again, they help with our air quality. All right. Living organisms reproduce to continue populations. Food sources. Okay, we know we get a lot of our food from living organisms. Okay, it involves cellular reproduction and energy use. Soil. Topsoil replaces old or missing soil. Natural resources at risk for being depleted. Fresh water. Depleted means it's diminishing, it's going away. We can't get it anymore. So fresh water there's an increased demand for fresh drinking water. And again, this is due to population growth with 7.9 billion people on our planet all needing water. Water's matter, it can't be created or destroyed. How do we get more water as we have more people on our planet? Soil. The lack of vegetation can cause changes to soil. So again, runoff, we talked about this with coral reefs. We know that runoff is detrimental. We know that the lack of vegetation in soil will reduce the quality of the soil. It'll become more dry and crumbly. It will not have the vegetation, for example, the decaying leaves and the decaying plant matter that actually provides nutrients and replenishes the soil. So vegetation means plants, plant growth. We need to have good soil in order to grow food. Plants, a shift in the carbon cycle. So this could cause a negative chain reaction. Again, plants, extremely important. Okay, we need plants for so many reasons. And when I say plants, I'm including trees and shrubs and all of that, algae, all of that. So think about it for a minute. What other natural resources are at risk of depletion? Depletion means their numbers are going down. There isn't enough of it to sustain what we have, what we need. Okay. So on page 14 again in class, we will be measuring our impact. We're going to be talking about our own carbon footprints. We're going to talk about what a carbon footprint is and how can we reduce our carbon footprint. Okay. So don't worry about page 14. We will be doing that together in class. So renewable energy, the top of page 15, renewable energy, again, energy that can be produced without much limit or restriction. These are the main areas where we are getting renewable energy. Again, wind, using those giant wind turbines to harness the power of the wind. It's great when it works. It's terrible when it doesn't. Biomass, using living organisms to get energy from them. There's so many examples, and we're going to spend a whole day on biomass. But one great example of biomass is there are some people that are developing, small engines that can run on used vegetable oil. So, for example, a restaurant is frying French fries all day long. At the end of the day, they get rid of that oil because it's been used up. It's dirty. They're not going to continue to cook French fries in it because they would taste terrible. And that normally they just dispose of that. But there are some smart people out there that are developing cars and other small engines that can run off of that fuel. So it's something to think about. But again, biomass encompasses so many different ways to get energy from living organisms. We'll be talking about that in class. Hydropower. You know what hydro means. Hydro means water. So this means harnessing the power of water, moving water, whether it's in a river. And here in North Carolina, we have so many old abandoned mills that were built on rivers. They ran using that hydropower. They were able to harness the energy that is in that river, that water moving downstream, to move different turbines in order to run their equipment. So hydropower, hydro means water, harnessing the power of water. This can also be used in our oceans. We have a lot of energy and power in our waves and in our oceans. Solar means sun. So harnessing that energy from the sun. This is probably one of the cleanest forms of renewable energy, and one of the ones that is being, you'll see it more and more in North Carolina. If you drive through to the Elon campus, you will see they have a huge solar field. And when you see those large black plates pointed towards the sky, they are absorbing. And in class, we're going to be creating our own solar equipment, and we're going to harness that power of the sun. Geothermal. So geo means earth, thermal means heat. This means harnessing the energy that is underground. The people next door to me actually have a geothermal heating source in their home. They are able to tap into that hot water that is underground and channel that energy to heat their home. And again, ocean, we know that there's a lot going on in the oceans as far as the movement of water. We've got the tides, we've got the wind and the waves. Harnessing that energy to power and get energy from is another area worth definitely investigating. So think about it for a minute. What do you think may be an advantage of using alternative fuel? Think of advantages. What are the advantages? When we say alternative fuel, we're talking about fuel sources that are not fossil fuels. Fossil fuels are non-renewable. There's only a limited supply. They can't be replenished as fast as they're being used. So alternative sources are solar, hydroelectric, geothermal, wind energy, and the ones that we just mentioned. So what are some advantages? But again, what are some disadvantages? Okay, what if you have solar hot water, which I had at one of my homes, and it's cloudy for 2 weeks? What happens? Do you have hot water, right? Do you have an electric backup? So we'll be talking about this in class, and we'll be recording it on the bottom of page 15. So again, advantages of renewable energy. Many are available indefinitely. So solar energy is going to always be available as long as the sun's shining, it's not cloudy, right? And as long as that sun is burning bright in our solar system. They cause zero or limited pollution. I like the limited pollution because they don't all cause zero pollution. We'll talk about hybrid vehicles and the problems with the batteries that power cars such as Priuses. Okay, there are definitely problems. They're not perfect. So what do you think may be a disadvantage of using alternative fuel, as I just mentioned a few minutes ago? And we will be discussing this in class and recording it in the space as well. So again, some disadvantages. Some of these alternative energy sources are costly to obtain or to harness. They're hard to efficiently harness and store the energy. How do you think these disadvantages may be overcome? So let's talk about wind energy for a minute. And again, we'll be talking about this in class, but wind turbines, those blades on those wind turbines, and I will show you pictures from when I traveled to Texas and Oklahoma a couple summers ago, but those blades are about the size of a football field. They're made of fiberglass and they do wear out. Once they're done being used, they have to bury them. There's nothing they can do to recycle that material. Okay. We're also going to talk about birds and birds when they're migrating from northern territories on our continent to southern areas, and the problems with birds and wind energy. So we'll be talking about these disadvantages, and you guys might be the generation to overcome some of these disadvantages. So I want you to be thinking about that. All right, so example, solar energy harnessed from the sun. The sun has more energy than Earth even needs, but it is difficult to capture and store it. It is hard to efficiently harness and store the energy. The following tools transform solar energy into electric energy. So solar power uses what we call photovoltaic cells. This type of cell changes light to electric energy. Light causes electrons to move, causing an electric current. So that is how we are able to use solar energy to power our homes. Solar battery, this stores energy from photovoltaic cells. And a solar reflector concentrates solar rays to make an electric current. These are used for industrial purposes. They confine or trap the solar energy, and doing this does present challenges. And we'll talk about the challenges. All right, so here we have a diagram, and it's also in your book on page 17. We have our solar energy from the sun. Right here you can see the rays coming down and being captured in the solar panel. The solar panel is absorbing the energy from these rays. The electron flow is going in a current here through these wires to power this light bulb. So conservation is we talked about it a lot in our chemistry unit, the law of conservation of matter or mass. To conserve means to save. If you are into wildlife conservation, as I am, you study different species and where they fall on the list of endangered species. And to conserve means to save, Don't think it's conversation. That is something different, right? Conservation. To conserve means to save. Your parents might say, conserve your energy. You have a game tomorrow. Or they might say, conserve energy by turning your lights off in your room when you're not there, right? Okay, you might hear them say these things to you. It means to save. Conserve means to save. So on page 18, there is a chart that, again, we'll be doing this together in class. We'll be talking about wind energy, solar energy, and how they work, what they have in common, any issues they may have. Okay. On page 19, there is, again, we'll be doing this in class, talking about why is conservation important? How can we preserve and protect our natural resources? How can water be conserved? How can ecosystems be protected? How can living organisms be protected? So we'll be, again, doing pages 18 and 19 together in class, so do not worry about those, as well as the application of the concept map on page 20. So we'll be doing those together in class, and we'll be going a lot deeper into the fossil fuels as well as the alternative sources of energy as we dive into this unit. Thank you for listening, and I hope that you have enjoyed this information, and I look forward to our discussions, which I know we'll have some good discussions and debates on this topic during class. Have a great rest of your day.